Hello everyone, welcome back to our channel. In today's video, we are going to discuss a very important matrix problem that is commonly asked in TCS NQT and other placement exams also. So the topic is Spiral Matrix Traversal. So before we start, subscribe to our channel and press the bell icon to get notified about more TCS NQT preparation and coding videos. So let's see what is spiral matrix traversal. So here is a definition. Spiral matrix traversal is the process of visiting all elements of a 2D matrix in a clockwise spiral order, starting from a top left corner, moving right, then moving down, then left, then up, and repeating this pattern until all elements are covered. So here we are using a 2D matrix. So we are going to traverse the matrix in a clockwise, right? So if we take this window, so if we traverse in a clockwise, we traverse like here from this box to here and we go down and we go left. So like this we are going to travel. So this is what clockwise, right? So exactly like this we are going to traverse. So exactly in a spiral matrix also we are going to travel like this. So let's see a sample example. So here is a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is a 3 into 3 matrix, right? So if we traverse in this matrix in a clockwise, we'll get like this. So this is what we'll get. So this is our output. So if we start from 1, 2, 3. So this is how we are going to traverse, right? So in a clockwise, we are going to traverse. So here start with 1, 2, 3 and goes to down. 6, 9 will be print and it goes to left side. 8 and 7 will be print and it's go up. 4 will be print and it's go to right again. So 5 will be print. So further we don't have any element. So we have 6 but 6 is already visitor. So we left this. So if we plan to go down we have 8. So that is also already visited. So let's leave it. So we don't have any element to move. So it will end the loop. So let's see another example. So here we have a 3 into 4 matrix. So if we traverse for this matrix, we'll get 1, 2, 3, 4 and 8, 12, 11, 10, 9, 5, 6, 7. So like this, we are going to traverse like a clockwise. So this type of problem is very important in TCS NQT because it checks 2D array knowledge, loop logic and boundary conditions. So this is very important. So this question will be asked in many placement exams. So let's see the scenario. So let's understand this with a simple real life example. So imagine a robot cleaning tiles in a rectangular room. So and moves right till the wall and then moves down, then left, then up. So after completing one round, it moves inside the repeats. So let's take this window as a rectangular room. So this window size also rectangular room, right? So what it says, it starts from the top left side. So if it's a top left tile, so it will come here, right? So this box. So let's consider this box as a tile and this box as a tile. So let's consider like this. So here what it say, it starts from the top left side. So this is what our top left side. So after it move right till the wall. So it move the right. So the wall is here. So it moved till the right. So we have reached the wall. So it will stop here. So and then what we they say, then moves down. So now we are moving on down. And so we have reached the wall. So then and left. So we are going to traverse to the left. So we have traversed to the left and we have reached the wall. So then we are going up. So we have gone. So this tile is already clean. So we just stay here, and after completing one round, so we have completed one round, right? So here after completing one round, it moves inside and repeat. So it moves inside. So one outer border is we have clean. So we have to start from the inner. So it came here and do the process again. So it will clean like this, right? So this is how the spiral matrix traversal will be. So this movement forms a spiral path, just like a spiral matrix traversal. So let's see the approach here. So in approach, we are using a boundary traversal method. To solve this problem efficiently, we use four boundary variables, which is top, left, right, and bottom. So we are initializing a value also. So if it's a top means we consider this as a top, right? So it is a first row. And bottom. So this is what our bottom, which is our last row. And left, this is what our left side. So it is a first column. So on the right side, that is what our last column. So we are traversing from top row, from left to right, and right column. So which is top to bottom, and bottom row. So which is right to left, and left column, which is bottom to right. So after traversal, we shrink the boundaries. So these boundaries help us to control the traversal direction and avoid repeating elements. So if this explanation is helpful, like the video and subscribe to our channel for more TCS NQT coding preparation videos. So here is a time and space complexity. So here time complexity is because m into n, because the 2D array consists of m into n size. So here the time complexity is m into n times. And a space complexity which is big of 1, because we are going to traverse each and every element for only one time. So we no need any extra spaces here. So let's see the algorithm here. So here initialize top equal to 0, bottom equal to row minus 1. So for the top, this is row, right? And here bottom, we are declaring row minus 1. So on left equal to 0, right equal to column minus 1. So if left is left equal to column, so which is a first. So left equal to 0 and right equal to column minus 1. So if it is a 0, so this will be a n minus 1, right? So which is column minus 1. So and in a while loop, we are checking a two conditions. So whether the top exit bottom or not, and left exit the right or not. So after checking these two conditions, which is top less than equal to bottom and left less than equal to right. So after checking these conditions, it enter into a while loop and traverse from top row, then increment the top value, and traverse to right column, then decrement the right value, and traverse bottom row. So if it's valid. So in some place we don't have, right? So if we traverse from left to right and right to bottom, and we have to check whether the condition we have, so is there any possible moves we can do or not. So if we have any, so of course we can go. So if there is no possible way to move, so we just end it. So for the purpose we are checking a condition. If the row is, if the top less than equal to bottom or not, or left less than equal to right or not. So here we are traversing bottom row. So if valid, then decrement the bottom. So and next after traverse left column. So if valid, then decrement left. So and print the traversal order. So let's see another. So this is our pseudo code. So the four values are initialized. Top equal to 0, bottom equal to row minus 1, left equal to 0, and left equal to column minus 1. So now while loop, we are checking a condition whether the top less than equal to bottom and left less than equal to right or not. So in a for loop, we are traversing from a left to right and print the matrix and update the top value by 1 and exit the for loop and another for loop. Create another for loop. In that loop, we are traversing from top to bottom and print the matrix and reduce the right value and exit the that for loop and enter into its condition. If top less than equal to bottom, if it is satisfied this condition, enter in a for loop and traverse from right to a left and print the matrix and reduce the bottom value. So if the left less than equal to right, enter into its condition and traverse from the bottom to top and print the matrix value and increment the left value and end the y. So let's code it. So let's create a class here, spiral matrix. So our main class. So inside our main class, we are importing our scanner. Is equal to new scanner, which is system dot in. So let's take a input for the n size and the m size of the array. So we are going to take a matrix, right? So int n equal to sc dot next int and int m equal to sc dot next int. So let's create an array. So int array equal to, so we are 2D matrix, right? So 2 array. So new int. So in one we get 2 and another one we write m. So n into m matrix. So let's get the input. So int I equal to 0, I greater than n, I plus plus. So another for loop, int j equal to 0, j greater than m and j plus plus. So array of I comma j equal to sc dot next int. So we have get the input, right? So here we have declared 4 variables top, bottom and left and right. So values are 0, top equal to 0, bottom equal to row minus 1, left equal to 0 and right equal to column minus 1. So int top equal to 0 and another int bottom equal to array dot length minus 1 and next int left equal to 0 and another int right. So int right equal to array of 0 dot length minus 1. So we have declared 4 variables. So in a while loop, we are going to check a condition top less than equal to bottom and left less than equal to right or not. So after these 4 conditions, 4 while loop we have to try. So let's do it. So in a while loop, we are checking the condition if top less than equal to bottom or not and have to check the condition if what is our next element, so left. So left less than equal to right or not. So we have to check the condition. So after checking these both conditions, we are entering into a loop. So for int I equal to left, okay, we are starting from left to right, we are traversing, right? So I equal to left, I less than equal to right, and I plus plus. So we are incrementing the value. So here we are printing the R element. So which is SOPLN in the array of top of I. So plus a space. Let's give it as a two space. So let's increment the top value. So top plus plus. So after this loop, we are creating another loop. So which is for top to down traversal. So for int I equal to top. So I less than equal to bottom. So we are incrementing the value. So inside the loop, we are printing that array of I comma right and adding a space here. So now we are decrementing the right value. So right minus minus. So after this loop, you are checking the condition. So if the top less than equal to bottom or not. So if top less than equal to bottom. So if it's true, it will enter into the if condition and it will go to the for loop. So on a for loop, int I equal to right and I greater than equal to bottom. And we are decrementing the value because we are going from right side to left side, right? So we are decrementing. So inside the for loop, we are printing that array of bottom and I under a space. So we are decrementing the bottom value here. So bottom minus minus. So we have traversed from left, right to left. So now we are traversing from down to up. So for that we are checking another condition. If left less than equal to right. So if the condition is true, it will enter into a for loop. So now for loop we are given a condition I equal to right and I greater than equal to top and I minus minus. I have made one mistake, a logical mistake here. So here won't be less than, here will be greater than. So we are decrementing, right? Yeah. So inside here, system dot output dot println. So array of bottom and I. And after that a space. So here, sorry. So here array of 5 and the left we are going to print here. So after the printing we are incrementing the left value. Okay. So let's run this code here. Let's see how it's works. So 3 into 3 matrix, right? So we have given input. So let's give an input for the matrix. So 1, 2, 3 and 4, 5, 6 and 7, 8 and 9. So the output we will get is, so if we do a spiral matrix, we will get the output like 1, 2, 3 and 6, 9 and 8, 7 and 4, 5. So it will came from left to right and top to bottom and from right to left, and it go up and go again the loop will repeat. So it will go to 5. So after that we don't have any element, so it will exit. So let's see. So we have got 1, 2, 3, 6, 9, 8, 7, 4, 5. So how 1, 2, 3, 6, 9, 8, 7, 4, 5. So we have got right. So this is what a spiral matrix traversal. So thank you.